Okay, let's take a look at the Hawaiian Island chains. Starting off with the oldest island. First feature that really pops out on us are these sediment lobes that float over the landmass. We can see that the front face is over here, indicating the current went up the screen from this direction. Then we also see some lakes, and then we find a marine terrace. See how nice and cleanly cut this cliff is? You can tell that's a marine terrace, and then very large river terraces coming across. Okay, you can see a sediment lobe right here. See that rounded edge? That's the front of the sediment lobe that washed around. So we see a connection between the sediment lobes and the marine terraces. Now that's a feature you're going to find all over the world. So check this out. This is another nice terrace. This is Kauai. Looks like there's multiple steps in these terraces here. But what's really cool about Kauai is it's got an amazing example of a U-shaped valley. Right, so the reason why this is interesting is because only glaciers are supposed to make U-shaped valleys. But the real answer to how a U-shaped valley is formed is a large amount of water that connects each side and decreases in a parabolic way. And then you can see this one here is also U-shaped, and there's kind of a terrace in there. And then this ravine here is an incredible example of a reverse ravine. So you look at how wide the ravine is up here. 12,000, 13,000 feet apart. And then we see that the canyon decreases as it goes downhill. Now this is an odd thing, but it's also a very common thing, common feature. And it has to do with water levels. Okay, let's go another island. We're actually going to skip Oahu for now and go straight to Molokai. This is a great cataract right here. Oh, it's a little dark, but it's a really nice cataract. It's a nice U-shaped cataract. So U-shaped valley, U-shaped cataract, all the same thing. This was made by a waterfall that had the width this wide as it formed this. That's how cataracts form. So that then gives us insight on how U-shaped valleys form, because they're interconnected features. It's just, you can look at it through physics and see what's physically possible. Now this is almost a mile, 0.9 miles, or 0.9 of a mile wide. So that's a very major cataract, but it's nothing compared to the feature adjacent to it. Look at this canyon. So you have water pouring off here to make a cataract, but then you also have water pouring over the ridge, forming this canyon right next to it that's a 1.5 miles wide, but it flows around this feature here, turning that into a mesa. That's how mesas form. You always find mesas in big canyon country, and mesas are just a remnant piece of land that was chiseled away. And so within this kind of odd shaped ravine, let's get a width on it, almost 3 miles wide. Within it, it kind of has a funky shape because it's full of so many cataract features. So you can see how this is rounded here. You can see how this is rounded here as a cataract. Now, if you were in, Alaska or something, everybody would be talking about cirques, right? Oh, from a glacier digging something out like that. But It doesn't have anything to do with glaciers, right? This cannot be a cirque. You know, they would say, oh, ice digs at the back wall, undercuts it. But we're right next to the ocean. And not only that, but we're right next to massive marine canyons. Okay? That travel hundreds of miles offshore. So the interconnection between the ocean, water flowing over a ridge, and marine canyons, as well as marine terraces and sediment lobes, all of that is telling us water origin. Now, how do you get a marine canyon? Why aren't there marine canyons everywhere, and why are they catastrophic? Well, how do you erode rock underwater, right? The only way you can erode rock deep underwater, hundreds of feet underwater, thousands of feet underwater, is with other rock, okay? The origin, and this isn't even disputed, the origin of marine canyons are underwater landslides. But it's more than that, because it's not just a landslide, but it's a current that's carrying a lot of boulders and other rock debris. Now, that's a feature of a catastrophic river, right? A catastrophic river is going to move boulders and deposit boulders into graded beds. But you turn that up in the ocean, and you've got massive boulders coming through and carving out these canyons. Well, if for as long as it's downhill, the boulders aren't stopping. They're just going to keep going, and they're going to make underwater canyons. And the underwater canyon keeps going, and here it's within sediment. This is the part where it's actually a mud flow. So no longer, when you get to here, this is all where all the rock debris is gathered. But then if you ever watch, flash floods and landslides, after the second part is the mud flow. And you should watch my video on marine canyons to get actual direct video evidence of what I'm talking about. But I'm just talking about Hawaii right now. Let's go to Maui. Maui's a sick spot. Look at this. Cataract, Reverse Canyon. Check out my Reverse Canyon video for more explanation. Another nice reverse canyon here. Let's check the width up here. 2.3. And then as it goes deeper underwater, right, all of these features formed underwater, the key to the width difference is the water depth. Now it's less than a mile wide. And then even less. Then look at how benign the river valley is. It's not very deep. And then the modern river, of course, is just a trickle. So when you study erosion, everywhere in the world you see massive decreases and reversing of strong rivers. Let's go. Oh, that's kind of cool looking. You get these cirques kind of positioned, indicating a current kind of sweeping across. Right, you can use a cirque to read the current direction and kind of get a sweeping current from these two cirques in particular. That reminds me of this spot over on the Big Island. Where is that spot? You're over here. Another thing you'd find with sweeping ocean currents is drumlins. Okay. So these are not lava rock. This is actually just sediment and actually kind of a reddish dirt. These are sediments, drumlins. So you get a little cross section where the water washed through it. It's, kind of a red dirt. These are drumlins. Drumlins, not related to ice. Cirques, not related to ice. Okay. All you have to do is study Google Earth for hundreds of hours and you figure it out, lickety split, or just watch my channel. Okay. All right, that was rude of me. I'm going back to Maui. This right here is cool because you see a terrace step. Terrace step, terrace step. And then kind of the ravine is over here. Kind of went towards that wall. And that's how when you watch a lot of rivers, they tend to decrease towards one side if you get a curve to it. Right? Centripetal force, right? It's all physics. Now, here's an interesting question I have. This rock, or this land here, is that lava rock, or is it a deposited dirt of some sort, or is it comprised of lava rock boulders, right? That's a question I have. I don't really get an outcrop to tell on this from Google Earth. And then it looks like these are kind of a little bit of ravines coming across here, a little bit of braided river formation coming across here. That would make sense, but these are really nice square, very level, very square, indicating river terraces. Very cool. Same with this spot over here, because this, it looks to me like something you'd find in New Mexico or Nevada, where sediment filled in. And I guess, can we see a cross section? Not very deep. Looks like there's some dirt here, but I wonder how deep or how much of a deposit this is. Now let's look at this feature and try to understand this feature here. Very odd. I'll just throw this out there. Plunge pool. You know what a plunge pool is? Because that is what a plunge pool really looks like. Then, which the back wall would be the cataract of a plunge pool, not a cirque or a tarn. And then you've got the river that's not even close to the same scale afterwards. So that's an unconformity in river width, but very nice example of a plunge pool. All right, let's make it over to the Big Island. Wow, do you find some nice cataracts? Send that in a postcard to Washington. Those are nice. Damn. Look at that. Look at the back wall of that thing. All right, I'm kind of talking dirty down. But check out the width on this guy. Almost a mile down. Nice cataract. That's a nice cataract right there. Dang. Let's check the width of this ravine. Over a mile. That's a nice ravine right there. Very nice ravine. And on a completely different league than these ravines here. So let's just take a look at the scale and the size difference. Whoops. Oh, those are the marine canyons. Talk about those later. You've got these ravines. They're all on a mile, a little under a mile wide scale. Then there's an unconformity in ravines, and we get the baby ravines that we see today. And then if you zoom in even more and try to find the current river, you know, that kind of only happens after a flood or after a rain, and it rains there a lot. But you see an unconformity. This cataract looks like a shallow cataract here. It kind of looks like a tree formation. Not sure. But oh yeah, so we get these nice cataracts that appear suddenly because that's what cataracts do. And then we have sudden ravines, which also form from water washing off of something, washing off a surface quickly. And they exactly fit. They exactly fit. These two sudden ravines exactly fit with these two terraces. Now this is something you find with marine canyons all over the world. And this is a very good example. Look at this feature here. This is perfectly connected. This is connected. This one, you'd guess that'd be a little stronger, but it's still connected. So we get a clear connection between these marine canyons and the sudden ravines / cataracts. Now, check this out. We already know from the cataracts that water's washing over this like nothing. Like it's nice and smooth because water washed over it and polished it, and then you get the cataracts afterwards. The exact rockage removed from these cataracts is what then cut out these marine canyons. And then that's the same stuff that's deposited here and here. And you know, this deposit here, you're gonna find boulders and stuff. Okay, now I'm gonna go to one more spot on the Big Island and call it a video after this, but this spot's gonna be really cool. So we've already seen that there's drumlins here. We already know that this is indicating a current direction sweeping across this little strip. Just like from the first island we saw, we had evidence of water sweeping over the landmass at quite a decent elevation. We've got drumlins indicating that here. Let's go north till we find these guys. How odd is that? We find 3 circles in an increasing order, almost like a snowman. This is a mystery. Now, you know what this reminds me of? The Columbia River in Oregon, right next to the Deschutes. And the Columbia River, which cuts right through the Cascades, that's another hint. But this is a relatively flat terrace. Terraces can have angles, but they can also form flat, and this one's relatively flat. This terrace and these potholes are just like the terraces and potholes found right next to the Washington Scablands and right next to the Columbia River. And they also form in a 1-2-3 pattern as well. So that's what they are. So we get the water, we get the ocean current coming across, and we get a river coming across this way. The intersection of those two features causes whirlpools, and then whirlpools then cause potholes. So that's how it is. That's how it formed. Water features all over here. This is a nice little lava flow that flowed around these. And you can see that when you have a lava flow like this, it becomes less terraced because now this has kind of a rounded bump to it. So this is an uneven landscape made in the modern day. But these incredibly flat terraces only became flat because of sheet water flow, just like river terraces and marine terraces. Therefore, this is a marine terrace. All right, you guys get it. Thanks for watching. And are these mounts? I mean, are these drumlins? I don't know. Stay tuned. Thank you guys for watching. Appreciate it. Goodbye.